Hello, everyone, and welcome to today's Webcafé session under the ELOQUENCE project. Like some of you may already know, ELOQUENCE is a Horizon Europe project that started in January last year. ELOQUENCE is pioneering the development of advanced voice and chatbot technologies aimed at transforming unstructured dialogues into comprehensible, safe, and unbiased interactions. Our focus is on creating self-learning, adaptable models for diverse languages and use cases, emphasizing sustainability and European values, especially in safety-critical applications. We aim to set new standards in AI, ensuring privacy, bias detection, and empathetic user engagement. And my name is Jelena, and I'll be moderating this session. Today, I'm joined with Javier García Gilabert and Miguel Claramunt. I hope I'm pronouncing it okay.
Yeah.
From Barcelona Supercomputing Center, who will help us better understand how we can detect and mitigate bias in AI systems. Okay, so for starters, could each of you briefly introduce yourself and share what drew you into this field? And perhaps one of you could tell us about the Barcelona Supercomputing Center's role within the ELOQUENCE project. So who is going to go first?
Yeah, I think I can go first. So my name is Javi. I come from the Barcelona Supercomputing Center. Well, we and Miguel, we are from the Language Technologies unit from the BSc. And inside the Language Technologies unit, we are in the Machine Translation group. That's what we will be talking today, I guess, about our work about mitigating biases in machine translation models. And I have been here for almost 1 year. I have a master's degree in artificial intelligence. And yeah, Miguel, I think that you can now introduce yourself, and then later we can talk about what we do in the ELOQUENCE project.
Okay, so in my case, I've been in Barcelona Supercomputing Center for almost 10 months. And in my case, I'm studying a master's at Universitat Pompeu Fabra. And that's it.
So we are a partner in the ELOQUENCE project here at BSc, and our main role is integrating the different pilots that are in the ELOQUENCE project in the interactive playground. We are also contributing in other work packages by supporting the different partners in deploying their experiments in the HPC facilities here at the Supercomputing Center.
Okay. Do you have, Miguel, something to add? No, okay.
No.
Okay, so we can now talk about your recent paper that you published, named an all-in-one toolkit for better machine translation evaluation. So Javier, can you explain to us or teach us what exactly is MT-Lens in simple terms?
Well, I think that before talking about MT-Lens or explaining why we decided to create this framework, maybe it's important to talk about machine translation evaluation and how it has been traditionally done by researchers. So usually when group releases a machine translation model, or big companies, they tend to evaluate these models by using metrics that tackle one aspect of evaluation in translation, which is translation quality. So usually there are like different metrics that can be used for evaluating this. Maybe we can later in the discussion talk a bit more about this. But these metrics focus on one aspect of evaluation, which is measuring the how similar translation is to some different reference translations, or how good is the translation quality. But these days, we know that these models that are out there for machine translation, they come with some of the biases. And there are a lot of papers that have investigated, for instance, gender bias in machine translation, the toxicity in machine translation, or cultural biases that these machine translation models can have. So the idea of making this framework was to make it easier for researchers or big companies to measure not only this aspect of translation quality, but also other aspects that are relevant for machine translation evaluation, such as gender bias or toxicity, that we will talk in the next questions, I guess.
Mm-hmm. So you mentioned gender bias. Could you explain what gender bias really is in the context of AI translation?
Okay, so gender bias in simpler terms means, well, in general, bias, it's an unwanted behavior that a model shows. And more specifically, in gender bias, it's when a model displays or shows a disparity between, for example, in this case, one gender or another. So, for example, when you translate from a language that doesn't have a really lot of gender cues, for example, English, into other that are more gendered, like Spanish or French, because there's no enough gender marks in the source language, it produces a stereotypical translation. For example, if you translate doctor from English to Spanish, the most probable translation will be masculine, even though doctor is like can both genders do it. And the same for nurse, which is like predominantly female job, but both genders can do it. So this is like the general problem that we have to want to avoid, is to make both translations as possible, because like it's the reality, like both genders can do this kind of jobs.
And what would you say would be the impact of gender bias apart from that social aspect?
So in general, yeah, well, I'm going to talk about the social aspects for a bit, because like, as we know, like there's a lot of problems around like gender, and for example, like some areas like STEM is like really male dominant job, area of jobs, that in this case, if you like perpetuate this idea of like people working in STEM are men, like this is like this avoids women getting into these fields. And the more like socio-economical thing is that, because when you want to translate for example a phrase into like these two options, for example the masculine and the feminine, the general problem is that when you try to translate for example something regarding a doctor into the masculine form, it's not a really big problem, because the model usually translates it pretty well. but when you try to translate it into the female form, there is some problems regarding of the regarding on the gender aspects of the language marks, that in general they tend to be more costly than translating to the masculine counterpart. So in this case, the comparison between a male and female translation implies like a 4x multiplier on costs regarding on time, and also like in salaries, because it's more costly to get like a female proper translation.
Okay, I think we can all agree that the problem is quite clear, but can you, Javier, maybe explain to us how do researchers measure something like this?
Yes, so as Miguel has said, this is quite a relevant problem in today's machine translation models that we have. And actually, there are not a lot of papers that investigate this or measure this kind of biases. We only have a few data sets that can be used to evaluate this. I think that I can count them with my fingers. It's just MASI, WinOMT, and ZenMT, basically, and another one which is bigger from Meta. But basically, what they have in common, these data sets for measuring these kind of biases, is they are English-centric, first of all. You have an English sentence, and you have different translations for the different variants of the gender. You can have feminine or masculine variants of the translation. Usually, the translations are in Romance languages, which are grammatically gendered. But for instance, I think that Serbian is also a grammatically gendered language, and it's not covered by any of these data sets. So there's still a lot of work to do. But basically, you have these two different variants, and what you do is you translate the English sentence by the model, and you compare how similar this translation is to the feminine or masculine variant. And you do this for a lot of different sentences, and at the end, you can have like a measure of how good is it doing for feminine or masculine translations. And something that maybe we can talk later is that there is only one data set that, apart from working only on text, it also can be used for speech, actually for speech translation models, which is quite relevant for eloquence, and it's quite related to word packets 2 and 3 that are working on speech large language models. And this dataset is MASI, that actually was published by FBK, which is one of the partners here at Eloquence. And they have the speech data, and that part of the dataset can be used to evaluate gender disparities and gender bias in speech.
We will get back to the speech translation a little bit later when we will be talking about the Eloquence project. But I wanted to, you mentioned earlier that added toxicity. So maybe you can first explain to us what that actually is and how can we measure that in MT, and then we'll continue in the direction you were suggesting.
Okay, so another bias that has been studied in machine translation and that we implemented in our framework is added toxicity, which basically means that if we have a sentence, let's say in Serbian, and we ask the model to translate that sentence into Spanish, sometimes we can observe that the model hallucinates, and as a consequence, it might generate a mistranslation or a hallucination that we consider toxic in the translation, even though that the source sentence has no toxic nouns. So that's what we say added toxicity. And it's something that has profound implications in the final translation quality that a human will evaluate. And there are different ways of evaluating it using automated metrics. And usually what you do is you have a lot of English sentences that are non-toxic in the source sentence, and you ask the model to translate those into any language you want. Especially in low resource languages where you will observe this more frequently. Then you have a classifier at the translation that detects whether or not there is a toxic noun. And that's how you can evaluate whether or not you have added toxicity in the translation output.
And what about misspellings? How can we measure that?
Yeah, so that's something that we have also implemented, and actually it's quite related to what I said with what I was saying about added toxicity, because sometimes this added toxicity can happen as a result of misspelling in the source sentence. So if you have a misspelling, the model can hallucinate more and therefore generate an added toxicity in the translation output. So there are different ways of measuring it, and usually what you do is to get some sentences that are, for instance, in English, and you modify that source sentence by adding some synthetic noise errors. So what do I mean by synthetic noise errors? So you can, for instance, get a word in that sentence and swap some characters or duplicate some characters or even remove some characters. And the more noise you add to a source sentence, the worse the system will perform, the worse the worse the translation will be, because the source sentence is more corrupted, so to say. So that's how you evaluate the robustness to misspelling. You increase the level of noise in the source sentence, and you evaluate how well the translation is as you increase the level of noise. And something that we have observed is that nowadays models, they are quite good at this robustness to misspellings, fortunately. And they have become more good over the years. And right now, we are at a point that high resource languages, especially English, Chinese, German, the models that we have are quite good on those languages and quite robust to misspellings. However, as always, for low resource languages, as it can be Serbian, for instance, the models are not that good for this kind of robustness to misspellings.
Okay, thank you. I think it's safe to say that we have a little bit clearer picture, bigger picture now. But let's talk about your personal experience. Maybe, Miguel, you can tell us what motivated you to focus on this specific challenge in machine translation evaluation, and was there a particular moment or a gap that made you realize MTLens was needed?
Okay, so as Javi previously said, there is a clear gap on literature on how to evaluate machine translation models and how to handle like a lot of problematics we have in this field. So MTLens was a project that tried to clear all of the problems at some point we have. For example, the main problem on evaluating the overall translation quality is like there are some metrics that are purely based on how the words are placed and if they are placed correctly or not. For example, if you put a word that doesn't make sense into the translation, it penalizes it. And there are others that are more like semantic. So they try to get the meaning of the translation and try to look if the both meanings match. But the problem is that they are really generalistic, and this means that the translation can be good in terms of metrics, but if you take a closer look at the actual translation, it will be errors regarding gender bias or toxicity that are not as wanted. So the fact that having the combination of generalistic and more specific metrics in terms of evaluation, it helps a lot on troubleshooting what the model is doing properly, what things we have to try to solve in terms of translation. And this framework in general helps us a lot on that task.
Okay, thank you. So Javier, we can now talk about what you mentioned earlier, speech translation. So do biases that we talked about exist in speech translation models as well? And can you elaborate on that a little bit?
Yes, sure. So before I was talking about one of the few data sets that we have for evaluating the gender bias in machine translation. And I was saying that we have this MASSI dataset that can be used for speech, and actually has been used for speech. So what the researchers did with this dataset was to evaluate how gender bias was present in speech translation models. So before that, let me talk a bit about what is a speech translation model. So usually in a machine translation model, you have text-to-text translation. You get a source sentence in English, which is text, and you ask it to translate to any other language. But in speech translation models, you get audio as input, and you ask the model to translate this audio to any other language, and the output will be text. So there are different kind of paradigms for this kind of models. So you can have first a model that transcribes the audio, and you then input that to a regular translation model. Or you can have an end-to-end model that takes into account from the beginning the speech audio, and then translates the output to any target language you want. So what the researchers at FBK did with this MASSI was to evaluate how or to investigate how these end-to-end models compare to cascade models that transcribe and then use a regular translation model. And what they observed was that these end-to-end models, they were better at using the gender speaker information for mitigating the bias in the translation. So let's put this in as an example. So you have the audio. I am a very good teacher. I am a male, so this in Spanish would be translated as soy un buen profesor, which professor is the masculine variant of professor in English. And as I am a male, the end-to-end model could have guessed that from my speech audio, and then translate it correctly and disambiguate this word into the Spanish translation. That's just an example, but they have a lot of more examples in the MASI data set. And it's actually a very interesting data set to use, and has been widely used in the literature. And we have also implemented that in our framework in MT-Lens.
Okay, so we can now talk about MT-Lens a little bit more. So what kind of visualizations or insights does your toolkit provide?
Yeah, that's another interesting thing that we did in this paper, because usually MT frameworks, they focus on implementing all the code for getting the metrics, and then you just get a score, and that's it. But we wanted to go a bit further, and apart from just giving a metric, provide an interactive way of understanding how these metrics and what these metrics mean. So we created a UI interface with different visualizations that can be used to understand, for instance, how the model behaves as you increase the noise in the misspelling synthetic noise. We have all the visualizations for understanding the gender bias with some examples of the incorrect translations that contain gender bias that the model has done. And you can even compare different systems in this UI. And so I think it's quite a useful tool that researchers can use for, apart from getting a score, visualize what this score actually means.
And Miguel, what do you think? How can this toolkit help build more trustworthy and fair translation systems? And how does MT-Lens connect to the goals of the Eloquence project?
Okay, so as this framework focus not only on the general metrics, like as I mentioned, that focus only on translation quality, and we also focus on like more specific metrics that will be useful like for us as a society in order to like check if the model that we are evaluating is at least has a somewhat level of capabilities that are suitable for like real world use. This tool can show us if the proper the model we are evaluating is on a spec to apply these technologies on like real world scenarios. So this tool mainly lets us debug some errors in the model that probably affect on like gender bias or other toxicity that they are these results are really unwanted if you deploy this system in a real case scenario. And so because connecting this to the Eloquence project, this as we try to get from this project a package that can be like used in a general use, like for with real users. This framework allows us to deploy technologies that are safe to all people and really doesn't discriminate regarding on gender or like other kinds of areas of our society. And because this is also tied to not only translation, but really like any model that we can that we can evaluate. So it's like you can apply it to a speech, to text, to a video, or to image. And like obviously you have to develop the evaluations for that. But in general, like this is the point, to really have safe models into production.
Mm-hmm. And so we're coming to an end of this Webcafé session. And to wrap things up, I'd like to hear your thoughts on this. So looking ahead, how do you see MT-Lens contributing to long-term objectives of Eloquence?
Oh, I think I answer both of them at the same time. So if we have this answer,
Maybe
I think it will
Javier
be
can
okay.
also give his
Oh yeah.
insights.
Yeah, so yeah, as well as what Miguel was saying, we have some core packages in Eloquence that are focusing on evaluating biases in current LLMs and aligning these LLMs to the European values. So I think that with MT-Lens, we can contribute to the efforts that Eloquence is doing for this purpose, for aligning the LLMs to European values, which at the end are the mitigating biases, and in the case of machine translation, mitigating also the toxicity and other biases that can appear in these models.
Mm-hmm. Okay, thank you both for sharing your insights, and thanks to everyone who joined us today for our Webcafé session. Are there any questions from our listeners?
Well, and thank you so much, Elena. Sorry for the interruption, for letting us the chance to talk about our work and having us here in the podcast.
Oh, thank you. I really enjoyed meeting both of you and learning more about MT-Lens. For those who are listening, you can find the publication we talked about on our Eloquence website under publications page. And also this session was recorded, so it will be soon online on our YouTube channel, and we will share it across our social media. So make sure to like, share, subscribe, and not to miss any updates from the Eloquence project. So if there are no other questions, I wish you all a nice and sunny weekend until the next session. Bye.
Bye.
Bye. Thanks.